Hi everyone. So I'm going to talk about two common flow control mechanisms that we can use in the network. So the first one is called stop and wait. The second one is called sliding window. So first of all, before we talk about any concept, there's one very important question is that why do we need that? So the question is that why do we need flow control? So let me show you one example. So we can see from this factory, the belt is moving very fast. And because it's moving too fast, the workers cannot keep up the pace. So what we need to do is that we need to slow down the belt. We'll need to slow down. So now we know the solution that we need to slow down. Now, let's apply the same logic to our network scenario. So in our network scenario, we have a sender and we have one receiver. The sender will send the data to receiver through the network. And for simplicity, we will assume that packet is the data unit here. So for example, in here, the sender will prepare one packet and then send to the receiver through the network. If the sender sends too fast, the receiver will get overwhelmed. For example, if the senders prepare a lot of packets at once and send all of them to the receiver, then the receiver may not have the capacity to process the data. So this will overwhelm the receiver. So the solution is that the sender should slow down. So we know that the sender should slow down, but this raises another question here. So another question is that if we know that the sender should slow down, but how can we do that? How can we achieve that? So in here, people have this idea called flow control to maintain a reasonable sending rate. There are two common flow control methods that we can use to do the flow control to maintain the sending rate. The first one is called stop and wait. The second one is called sliding window. So let's see the overview idea for the stop and wait here. For the stop and wait, the idea is that the sender will send a packet to a receiver, then the sender will stop and wait for the ACK immediately. Now the receiver receives the packet, then the receiver will send the ACK back to the sender. Only after the sender receives the ACK, the sender will proceed to send the next packet. Then the sender will stop and wait again immediately, and then repeat the process. So that's the idea for the stop and wait. How can we visualize that? So in here, we have a sender and we have a receiver here, and this is the time. So the sender will send the first packet to the receiver and then enter stop and wait again immediately. And the sender will be waiting for the ACK from the receiver. The sender will only send the next packets after it receives the ACK from the receiver. Now, after sending the next package, the sender will stop and wait again, and then waiting for the ACK from the receiver. So that's the main idea. That's how we can visualize this method. Now, if you see from the this example, we will see that there's a limitation for the stop and wait. The bandwidth utilization for the stop and wait is too low, and this can lead to inefficiency and low throughput. So here's one way that we can visualize the bandwidth utilization for the stop and wait. So we have a sender and we have a receiver here. And then this is the time. This is the time from when the sender sends the first packet until the sender receives the first ACK. Now, during the time, the sender will spend some time to send the packet and then will spend the majority of time for stop and wait. Now, if we compare the time proportion, we will find that only a very small time proportion is used for sending the data. But the majority of the time proportion will be spending on stop and wait. So this will lead to very low utilization of our time and also our bandwidth resources. So the question is, how can we increase our bandwidth utilization while also maintain the sending rate? So people have this another idea. We can use something called sliding window. So sliding window is also a flow control method, but can help us to increase bandwidth utilization. So the main idea here is that we will send a window of packets instead of just one packet. So how can we understand the word window here? You can understand the word window here as a group. So we will send a group of packets before we stop and wait. So let's visualize that. So we have a sender and we have a receiver here. Now the sender, instead of preparing just one packet, the sender will prepare a window of packets and then send this window of packets to the receiver. This can help us to increase the utilization. Now let's visualize this again. So we have a sender, we have a receiver, and this is our time dimension. Now the sender will send a group or window of packets, and the receiver will send ACK for each of the packets. Now in here, the sender can send next packets when the sender receives the first packet. So if we compare the time here, we will find that now the idle time here for stop and wait has been significantly decreased. So less time on stop and wait, and this can help us to increase the utilization. So in summary, sliding windows spend more time on sending packets and spend less time sitting idle. Let's try to visualize the utilization again. So we have a sender, we have a receiver. Now this is the time for the sender to send the first packets until the sender receives the first ACK. So the sender this time, using sliding window, will send 4 packets and then enter stop and wait. Now, if we compare the time proportion, we can see that now the sender spent more time proportion on sending data and spent less time proportion on stop and wait. So this significantly increase our utilization. So we can achieve high utilization using sliding window. Now, there's another question. So where can we use the flow control method that we just talked about? So both the stop and wait and our sliding window can be used on transport layer and data link layer. Now the question here is that, what are transport layer and data link layer? So here's how can we visualize that. So we have a sender and we have a receiver. So we say that the sender will send data to the receiver through the network. Now we know that there are intermediate routers in the network. The link between the router is the data link layer. And usually they have short distance because the intermediate router, usually they are closer to each other compared to our sender and receiver. Now the logical link here between the sender and the receiver is considered transport layer, and they have longer distance. Now, given the properties of the data link layer and also the transport layer, we can summarize the effects when we apply stop and wait and sliding window on both layers. So in here, we have a stop and wait flow control. And if we use the stop and wait on data link layer, the benefit is that it's simple because the mechanism of the stop and wait is simple. So we can use a cheaper device to achieve that. And I will say the efficiency here will be okay because the data link layer has a shorter distance compared to the transport layer. So if we use stop and wait, we don't have to spend that much time waiting for the ACK traveling back to the sender. So the efficiency and throughput can be okay if it is used in data link layer. However, if we use stop and wait in transport layer, the benefit is still very simple, but it could be inefficient and low throughput because in the transport layer, the distance is longer. So that means the time for the ACK to travel back to the sender can also be longer. This implies that the stop and wait time proportion will also be longer. So this will affect our efficiency and our throughputs. Now, if we use a sliding window on data link layer, what will happen? So sliding window is complicated because now this time we send a group of packets, right? So we need to maintain the state for each packet. So it can be complicated. If we use that in data link layer, that means we will need to use a more expensive router to do that because now we need more processing power and more memory space. But the benefit is that we can still achieve a very high efficiency and throughput because sliding window allows us to send a window or a group of packets at once. Now, if we apply the sliding window on transport layer, it's still complicated, but usually we think this is okay because the computer of the sender and user in the transport layer, usually they are pretty powerful. So it's okay for them to handle the sliding window. That's why in practice, we usually see people use sliding window in transport layer. That's one of the reasons. The benefit is the same. We can achieve high efficiency and throughput if we use sliding window on transport layer. So basically, that's the summary when we use stop and wait and sliding window on different layers. That's all about the class. Thank you.